Hello everyone, welcome to Tech Solutions. Here in the playlist of scenario-based question, I will be next discussing about the internal working of like a live data, but more like it is like we will be discussing about how internally live data works, and then we will be discussing about creating a custom live data on our own. So it is a general. Scenario based question which is generally asked in an interview question, in a scenario based question with a person with an experience of 3 to 5 years, I mean greater than 3 years of experience, that he or she should be aware about that how internally our live data is working, which all methods and observable methods, everything it is like taking help to give us the uh, how give us that life cycle aware component that actually provide our data in a real time. Um, we will be starting with like a basic definition of live data. Live data we know in an mvvm architecture we generally, this is in a live data component is a ZK component that provide us with an option to observe our data in a lifecycle aware manner. So we do not need to manually handle that a lifecycle thing. We can just observe it and it will check after that our uh, lifecycle of our associated component. So generally like we use it with the view model thing. And like for the view model part, if you want to see a video how view model works internally, we have like a previous video which actually deep dive into like how view model works internally. So now we will start like with the firstly I will start with the like how view model works internally, sorry, how live data is like working internally in the first part, and the second part of the video I will be showing like how we can create a custom live data on our own. So these two are the important topic for this live data. So now let's start. So here I will go with like part by part. In the first part I will show what are all the basic constructor and method which live data is actually using to like work. So if I go with this live data method, if you say, so it is an abstract class which is holding a lot of other method objects, and objects and methods and parameters, everything. So if you see here, these are not that much important to us for now, not for now, I mean these are important but not for now, which is not important to us. But this aim observer object is very important to us. So it is a map which actually uh, saves our data in a like uh, what is a key value pair. So it's an observer wrapper and observer, so it will be like it will be saving the event and the value uh, as required while when we will be fetching the when we will be like observing the change in event. So this we will discuss like in more detail in the later part, but before that we will go with the basic methods. Like we have this, if you see here we have that constructor like initializing the live data with providing value or without value. So these are the like some constructor and basic live data. And similarly for the mutable live data, if we go, so it is generally calling a super method, and the super method is like again it is opening the same live data without value assigning to it. So if I go like these are two important method we should be aware, like post value and set value. For some it will look similar like we are posting the value, but it actually a different thing. If we go in that super thick method, will show you. So like the set value, we generally use set value when we call this method in the main thread. So like if we are working on a main thread directly, so we can use the set value method to set the value of any live data. But let's suppose if we are doing some network fetching and we are on the background thread, and on the background thread only we want to uh, update our data, then we need to use the post value method. So you see it is clearly mentioned here, the method must be called from the main thread. If you need to set a value from a background thing, then you can use a post value. So these are two like basic methods and the constructor I have discussed of the live data. And now I will be moving to the main activity. So here I am actually observing my live data. So I have it a view model, and the view model provide creating an object of view model. So again, if you want to look after that how view model works internally, you can look into our another video in the given playlist. And for the observer, now I will start the real implementation how actually our live data is working. So with the help of our view model object, we are actually taking the reference of our live data, and then we are observing it. So this is the main method which actually helps us to like look after the change in event and observe the changes, and then update our uh, update our UI or the data in our UI. So if you see, we have like two parameter passed here, this and observer. So I can for just for a recall observer, we have before live data we were using observer. And what is the basic difference for like a small information if I can say? So live data is a life cycle aware component and observer is not a life cycle aware component. So while we were using observer, we have to manually provide that life cycle observer thing, and based on the change in the event we were actually changing our data on the UI. But now we are using the live data, so it will do it on its own. So we are actually using the observe method, and observe method actually take two parameter. It is on the life cycle owner, and another one is the observer. So for the owner part, we have passed this. So in the view model internal working, I have discussed about this lifecycle owner part as well. So I will recall quickly here. So this here means we are passing the main activity, but observer is asking for a lifecycle owner. So I have remember that main activity actually inherit app compact activity. App compact activity actually inherit fragment activity, and fragment activity inherit component activity. So component activity is actually implementing our lifecycle owner. So it is a hierarchy, and in the main activity we are not directly implementing that lifecycle owner, but our parent is actually implementing. That's why we are not getting here, because our parent has implemented that. So when we pass this, we are actually passing the main activity, but internally we have already implemented our lifecycle owner, so that's why we are getting this one. And then we have this observer part. I should clean this. Yeah. So observer will be like whatever change in the data, so we will show it into the UI. So like we have the count here, and the count with the data will be changing. So we are observing if there is a change in data, we will update it to our text view. That's it. So now we will go into the internal implementation. We came into here observe method. We have that owner as we discussed right now, and this observer which will actually observe the change in the event. So these things all happen into the like main thread. So that's why we have this assert main thread. Nothing to worry about this one. Yeah. So the first line of code we have in the implementation is it actually uh, perform the main task that has its in definition, that it is lifecycle aware component, and if the associated component is not activity, it will not send the data. So we will it is actually performing it in the first line of code only. If our current state of our owner is destroyed, we will just return it. So the what is the owner here? So owner, we have we are actually observing our live data in the main activity, and in the owner part we have passed that this. So that means our main activity is currently our owner. So we actually check the life cycle of and current state of life cycle of our owner. If it is destroyed, we will just return, and if it is not destroyed, sorry, so we will go into the next line of code. So if our activity is destroyed, nothing to worry, it will not send any data. And when our activity will again come into the active state, it will get the last data that live data had, and it will show that data to you. So this one is the actual implementation of what actually the definition is. And then we will deep dive like how it's actually doing that. If it is in active state, how it is sending the data. So we have one class lifecycle bond observer. So it is a wrapper class over an observer class. So it provides us the like various implementation. So we will go in each class one by one. Like I went to this one. You see here we are extending the observer wrapper class and implementing a lifecycle event observer. I will go one by one. If I go to lifecycle event observer, so it is an interface which actually inherit a lifecycle observer, that is to observe the lifecycle change in the event, or what is how the lifecycle of that associated component. And if you say, you can directly say like this class that can receive any lifecycle change and dispatch it to the receiver. So if there is any change into the lifecycle of the associated component, it will dispatch it to the receiver. Receiver here is our live data. So for this on state change method, this implementation the implementation of this one. Yeah, the implementation of the on statement method is here in front of us. So we will discuss this as well, but before that we will check it above. So this is the event observer that is implementing, and it has an interface, and it has a one method that we are implementing here, and then it is extending an observer wrapper. If you go that observer wrapper class, so it is actually checking if our activity is active or not. So if I show you here, there is an observer wrapper class. It is actually doing this one, what we say, yeah, it is actually initializing the observer variable, and then it is should be active. So it is again an abstract class. If we see its implementation, lifecycle bond observer, you see, so it actually just check like if my owner lifecycle current state is at least started. If it is at least started, it means our activity or the associated component is in active state. It just check this. So if we come here, it attached to, if it is attached to our lifecycle owner or not. Basic of the methods are here. So we will discuss one by one. But before we will go to sorry, we will go back to our that observer wrapper class, lifecycle bond observer, which extend it. So we have one method which is called like on a state change, right? And we have other observed like it as the observer when we are not in active state. So if you see, when we have like that, what we say, when our life cycle is sorry, the associated component is not in active state, we deattach the observer, and internally we are removing the observer. And if attached to, if we are attaching our owner with that owner that we have passed, so we are now attaching it. So now our live data is attached with our owner here, and we, it is in active state, it will return active state because it is now has been opened. And now in the on state chain, the main thing happened here, like whenever there is any change in the state of our associated component, we will come here. We, so what we check is like current state. So again, if you see the code, we are actually checking the current state of our owner. Again, if it is in current destroyed state, we will remove the observer. Just remove the observer because our activity has been destroyed, nothing else, just return it from here. If it is not destroyed, what we will do is we will make the previous state as, we are creating a variable here, and like we're doing a while loop or something, like swapping the variable. And where what we are doing is current state, we are giving the current state as our whatever the current state of our owner, and making the previous state as like the uh, uh, current state, that is like the previous thing. And now we are doing one more thing here, active state change method, which is has been called from the observer wrapper class only. If you see here, so I was just what to discuss here. So what we are doing is, we are here what we have passed. Okay. Mm, if you see, we have passed should be active. So like let's suppose it is in currently from a started, it went to like on resume method. So it is on resume method, it will return true. So in the active state change we are passing true. Okay, here we gave true. So then if new active is m active, I mean what is m active, we have initialized it. Okay, so if we see, we have initialized it somewhere. Hmm. No, for the this time, like I'm a bit confused here, so we'll look into it later. Otherwise, what we will do is, if we email say text, so we never display anything. So if it is uh, if it is if m activity is true, new active, we are getting new active as true, and so we are passing m active as true here, and we change the active counter. It is counters are just basic thing. And if it is a main activity, uh, if my activities in active state, we will start dispatching the value here. So if you see here, the dispatching value, the main, which is, this method is actually used to say and dispatch our data. So here we are passing a initiator. Initiator is coming from that observer method only. So if you look into the initiator part again, we are passing the this, and this is our that observer wrapper thing. So it is an initiator to like, sorry, sorry. Okay, so if you go the code like one by one, if dispatching value, so it is like a global variable, and dispatch validated is again. So time is coming, I go with that directly, the like where we are actually initializing it. So we are initializing it here only, true and false. Default, by default we have provided it nothing. So it will be closing soon. So I will be discussing it more in deep. So we will understand that parameter first. So we have observer wrapper initiator. So it is like the parameter is used when like a observer is explicitly requesting the data. So it is not always necessary to notify all the observer at once. Sometimes only the initiating observer need to be updated. That's why we have the initiator here. And here if you see the m dispatching value, so m dispatching value is a flag here which is used to prevent the recursive notification. When it is set to true, it indicate that live data is currently dispatching update to observer. So it is actually, if it is actually dispatching updates to the observer, so it is not to like come into a loop, to like always come into a loop. So it prevents the re-intro into the dispatching loop, which might happen if live data change multiple time while observers are being notified. So while the observer are getting notified, and meanwhile the live data are getting changed a lot of time, so it will go into a loop. So it this is actually provided to prevent the re-entry. So like if it is already true, then it will make the invalidation as true and just return from here directly, so no looping here. Then we have the m dispatches invalidated. So what this flag do is, if there is a change in the live data and during dispatching, so like meanwhile like when we are dispatching the data and in the meantime some new value being set to the live data, so the live data change during dispatching, so it is used to set so here we set it to true. So it is generally what it does is it force the loop to restart. So it force the loop to restart, so it actually ensure that observer got the most recent data. So let's suppose we are actually dispatching the data, and the meanwhile the live data gets set again, and so we will and we didn't do anything, so we will not get the recent data like quickly. So what it actually do is it actually invalidate the current data and force the loop to restart, so that we can get the recent data. So how we are actually handling it here, everything is, so let's suppose we have an initiator. If an is an a specific observer is passed to the method, like we have some here, like some observer want the like data right now. Say we have explicitly passed an initiator, so it will be not null here. So what we will do is, it meant that observer needs some immediate notification, so this method will notify only this observer with calling the method. So we have this initiator here, so we are passing this initiator. So this method will do is, it will only notify this particular initiator or the observer about the change in the data, and then make it the initiator as the null. But let's suppose if there is no initiator and we have to send the data to all the observers, so it will iterate through all the observer, and then notify to each observer here. So it and then what it do is, and this method also ensure like we have here, if you see, with addition, this method is actually doing is, if while dispatching the data, if there is any new observer coming there, so it will add it that observer also in the list. So every other observer who is in the list, I mean who is in the place, and if any new observer is also coming, it all will be considered and they will be notified about the change in the data. And then we if it is a and if it isn't like for true, then it will be break from the loop, and there will be no any data. If it is set to true during the notification process, indicating that a new update had been occurred, so the method break out of the loop and restart the process do while loop. So every do while loop, and then we will be sending the data. Otherwise we will not get the actual data. So once all active observer are notified, the m dispatched flag is set to reset to false, allowing future notification to be proceeded. So this is the one. So consider notify, if I go to the consider notify, it actually notify the change in data. If you see on the change in data, it is passing the data here. That's like we will look into it later if will have time. But I don't think we need to. I think that's enough. These are the all the internal implementation and basic thing we actually do while going for live data. Yeah, if I will be missing something, okay, we have missed something. This variable I had talked about. Mm, okay, so we will discuss this. We actually miss a lot of things with this M observer also. So what we are checking here is we are again creating a object for an object wrapper, and what we are actually passing is an M observer dot put if absent. So first, if we go to the object wrapper, if you see, we were doing is we were active state change, and then we were dispatching value and all those things. So here, if you see, we were passing the initiator. Initiator means the object wrapper. So object wrapper, like if any observer wants the data explicitly, so we will pass that initiator that okay, pass this observer the particular data. So that observer will only get the data at once and not other observer. So this can be the condition. So here, if you see, what we are actually doing is we are creating an aim observer that put if we have if we uh, if the specifier is not already associated with a value, we will associate it. So what we are doing is aim observer is a map, and we have discovered it is an observer, observer type T. It can be anything, and we have that observer wrapper. So we are passing as a key value. So if you see here, we have key and value. So we have the observer as the key. Observer, whatever change in the data, so whatever changes we are getting in the data, we will be passing it as the key, and the value will be our wrapper class. So wrapper, that means it will be the change in the event. Whatever change in the event, change in the active event, that means the active state of our associated component will be passed here. So what we are getting here is from the lifecycle owner. So we are checking if on a state change. So if there is a state change, we are getting the state change here, the owner and everything we have here. So we are actually passing the observer, that is the change in the data, and the wrapper, it is the lifecycle events. So we are passing it to the our existing, I mean the one of that object wrapper, that is in the next method it will be an initiator. So what we are actually checking, if existing is not null, I mean we have something in an observer, and if it is attached to on. So if it is already attached to owner, and we have an observer, but it is already attached to an owner, so this method actually prevent like adding the same observer again and again to the same owner, the same owner. So this is actually like cannot add the same observer with a different life cycle. So like we have a different life cycle, means we have a different life cycle, like we are on, resume, on, pause, anything. And but the wrapper said, I mean this value said it is in resume method, and we have one observer, but sorry. So it will not save it, so it will prevent it from like adding the same observer with different life cycle. And if existing is not null, I mean if we have something already there, so it will actually return, nothing will happen. But let's suppose we have not our current what do you say, our current observer or the current data is not has been added to an observe method. So what we will do is now we will add to that as an our that wrapper, that is the change in the event, now that will be added to being observed. So uh, to observe the change in the event, so whenever we create an custom live data, we create some add observe method, like which we will be using to observe the changes. So to observe the change in the event, we need to add that change in event, that is the owner's life cycle, to be added in our method where it can be observed. So here this is the add observe method, which is actually used to observe the change in event. So if I show you, it is an abstract method. We can check the implementation. It is a long method. So what it is doing is checking all those state, like if it is still destroyed, then destroyed, otherwise it is initialized. And we have a lot of thing here. So basically we will go with the definition only. So it is a life cycle, add a life cycle observer that will be notified when the life cycle owner changes state. So it is like the given observer will be brought to the current state of the life cycle. For example, if the life cycle orange started, say, then the given observer will receive on create. Okay, so it will give us then event change. So we are getting the event change here into the wrapper, and then wrapper will be used for getting the existing, and then we will perform all those things. Okay, so this was the basic internal implementation of live data. This could be more, and it could be defined more clearly. So this was my understanding, that we are using the lifecycle owner and the lifecycle pond observer. Lifecycle observer, mostly I say lifecycle event observer, to observe the change in the event, and if it is destroyed, we remove the object. Otherwise we call that active state change, and it will check for that if it is inactive or not, and then based on that it dispatch the value. So the overall summary could be, it is like, when we have a live data we are using, and we are observing it, we pass that owner and that the change in observer, that is whatever data change is happening, and these two we is get used here to like save it into a map as a key value pair, the change in the state and the change in the value, and then we actually check it if it is all, if our and some any of the observer is already in that map with some different life cycle. If it is in the same map, we will do nothing, we will throw the error, sorry, and if it is already there, then we will just return. Otherwise, if we will add it to add our change in the event and the lifecycle owner with an observer, so it actually will have to like observe the lifecycle, which will receive the sorry, actually I'm get confused here again. So it is like basic thing, we have lifecycle owner, we have lifecycle event observer, which observe the event, and we have a wrapper class which actually wrap over that on a state change method. And if we are in active state, it actually dispatch the value in the effective state change, then we will be dispatching the value. And we have the option here, like if we have want and change in data for particular observer, then we will go with the initiator. Otherwise we will iterate through all the observer, and if it is attaching more in the meantime, we will edit that observer as well, and then we will change pass the data. So these all are happening, like we have methods like to check active state of our component activity. So it is happening with our owner, that we lifecycle owner. So it is important to understand the owner very clearly. So lifecycle owner, we can I could create a video in the life cycle owner in maybe in the next next some video, what lifecycle owner. So lifecycle owner is actually very important. It has been used in view model, it has been getting used in live data. So for any lifecycle aware component, we actually need the owner. So owner will be like the associated component. So we this is the like I mean could be a basic summary of uh, live data, and it could be more. I think this was my basic understanding. And in the part 2 of this live data series, I will be discussing to create a custom live data, how we can create a custom live data. Again, that too will be a basic live data that will only be performing that operation based on the life cycle event, and not other major part of the live data it can perform. So yeah, that's it. Thank you.